Welcome back everyone. So in the last video we solved now one function call, and in this video we are going to solve Memoize, which is a medium question. Okay, so we are given a function fn. We have to return a memoized version of that function. A memoized function is a function that will never be called twice with the same inputs. Instead, it will return a cache value. Now you can assume there are three possible input function: sum, fib, and factorial. Now let's say sum accept to integer a and b and returns a plus b. Now assume that if a value has already been cached for the arguments b comma a, where a is not equal to b, it cannot be used for the arguments a comma b. So if we have called sum for b comma a, then we cannot assume that the result for the a comma will be same. So we'll have to call that function again. Okay. So for example, if the arguments are 3 comma 2 and 2 comma 3, two separate calls should be made. Now fib is another function. So let's say it's accept a single integer n, returns 1 if n is less than 1, or fib n minus 1 plus fib n minus 2 otherwise. And the other function is factorial, accept a single integer n and returns 1 if n is less than or equal to 1, or factorial of n minus 1 multiply n otherwise. Now let's see an example. So first function name is sum, and we called two times, then we get call count. These are the internals of LeetCode, how they are solving this problem. So these are the values that are passed to this sum function. So initially it is passed 2 comma 2, so it will return 4. So a call will be made, separate call. Now the second time 2 comma 2 is passed, again the same number of arguments with the same value. So a and b both are same. So there will be 4, but no separate call to the sum function will be made. Then an empty array is passed. So in that case, so this empty array means this get call count. So this is not related to us. Now then 1 comma 2 is passed. These values are different. So we'll do a separate call that will return 3. Okay. So these are the three calls made. The first one, the second one, and then these three. These calls are internal to how LeetCode is solving this problem. Let's see example 2. So this is a factorial. So in the first case, call to 2 is made. So it depends on how the factorial function is called. So if it is recursive, it will call for 2 then 1. Okay, so for a call for the 2 is made, which means it will invoke the factorial function, so it will return the result. Then again the call for the factorial of 3 is made. So again a new call is made for the factorial of 3. But if it is recursive, for example, then factorial of 2 and 1 will also be made. But we know that the factorial of 2 also cache factorial of 2, factorial of 1. So only a call to 3 is made. If this function recursively make calls to 2 and 1, then that calls will not be made and the cache value of those calls will be used. Okay, let's see example 3, fib noic. So fib of 5 is called, a call is made, that's it. Okay, there is no new function call. So let's solve this function. Okay, so now, so you see, as per the given question, there will be only three types of the function: sum, fib, and factorial, and that doesn't matter actually. Okay, so let's see this commented section. So they have created a function, Memoize function, and in this Memoize, they will pass another function. So this is the another function. Okay, so this Memoize will return a memoized function, and then they will invoke this memoized function with some value. So this memoize function will memoize a function. Okay, so that function will be invoked with some values of a, b, c, d, or whatever values. We don't know what that memoize function will be called for. So this function will accept something, and in what format we don't know. So what we'll do is we'll return a function. This return function uses spread operator this. So this will collect anything inside the args. So this memoize function will collect anything, and this collected value will be like args equal to 2 comma 3. So this is how we will collect everything passed to memoize function. Now we'll have to call this function. It depends on we will use the cache value or not, but let's say we'll have to call this function. So when we'll call this function, we have to pass the values like this 2 comma 3, but we have collected this as 2 comma 3 in the array. So we will use Function.apply. So object.apply. So this is this apply function. What it will do is it will pass these array of values as 2 comma 3. Okay, so let's see how we'll do. So first, how should we cache these values? Okay, so this is the function and we'll have to cache. So we create a cache first. So const cache. So this cache is an empty object. Now how will we determine if this is a cache hit or not? So let's say Memoize function is called with 2 comma 3. Okay, again this is called with 2 comma 3. So we see these two matches, a comma b and a comma b, both are same. This means this is a cache hit and we should use the cache value. So first we will create a cache key. So const cache key. This key will tell us whether the call made to us is already made before or not. So how will we create the cache key? So cache key is nothing but we will join these inputs, that is where 2 comma 3. So let's say we'll join as args dot we'll do join. Okay, and we'll join them by underscore. So how will this looks like? So for example, if you are passed 1 comma 2, then this will become 1 2. Okay, and let's say you are passed with 1 1 comma 1 comma 2, then this will looks like what? So let's see what it will look like. Copy this value and open the inspect window, and inside the console what you can do is join this value using underscore. So this first one is joined like this and the second will be first converted to a string. So let's see how string conversions work like. So we'll do to string. So this is converted to string 1 comma 2. So this is 1 comma 2 and then it is joined by underscore. So the simple thing we can do is instead of joining we can do to string. Okay, so this will return 1 comma 1 comma 2. So what we'll do is we'll simply call toString on this function. Okay, so this is a key. Now we will see if this value already exists in the cache. So if there is a value cache key, then what we'll do is we'll return the value of that. We will not do any call. So we'll return this. Else we will store the result of the new function call. So we'll do function.apply. We'll pass null and we'll also pass these arguments. So the result of the fn.apply will be saved inside this key, so that next time this same function will be called, we'll calculate this key, we'll check if this exists in the cache. If these, then we'll return that cache value. And if it doesn't, then we'll call this function, save this value inside the cache against this key, and we'll return the same value. Okay, so let's see. So all the test case has been passed. Okay, now we'll try to submit this. And our solution got rejected. Why? Because when someone called with 0 0, one call is made. When someone called again with 0 0, again one call is made. But it should have used the cached value. But instead of using cache, it did one call again. So what this will return is get call count return true, which means two calls were made for these two values. Now let's see why. So first we have received args. So those args will be first, initially this will be there. So this will be there 0 comma 0, and toString what it will do is it will do 0 comma 0. So that will be the cache key, that is args.toString. And inside this cache we'll check if this cache key has some value. If there is a value, we'll return that value. Else we'll store the value of this function but apply those args. Okay, so we'll use this test case. Okay, so there was a problem in this cache key we are checking inside the cache. So can you see the problem here? What if the cache key value is storing something that is false? So let me show you an example. So we'll copy this function and open the inspect window, go to console, and let's paste this function. So this is Memoize function, okay? So what we'll do is we'll print the cache here. So console.log cache, okay? And now let's memoize a function. So constant sum is memoize a function that accepts two value and return a plus b. Okay, so first we will call this function with 0 comma 0. See, our cache is empty. Here it is empty, but the next time it will be we'll put the value. Now let's call this function again. You see, we have the key and the value is 0. So when we check that if the cache has this cache key, so what it will return? Cache with cache key. It will return 0. And 0 is false for if there is a cached value inside the cache, but the value is 0, and if we create the 0 as false, so it will do a next call again. So what we have to check instead is that that value is not equal to undefined. That's the only check we'll need to correct these mistakes. This value not equal to undefined. Okay. Okay, so now all the test case has been passed, and now we'll submit this to see if all the test case can be passed or not. Okay, so our solution got accepted. So the bug was that even if there was cache with the cache key, we are calling that function again and again only because the value for that cache key was falsy. Okay, and that we have avoided using a check which will check if the value is not equal to undefined, which means there is some value against this cache key.